Okay, we could see, you could actually see what change was made to accommodate the not having enough to meet the demand. That's in the sheet, I think, number 3, like it says Foster optimal number 3. Here is the result. Okay, here is the result. And there's all kinds of highlighted cells, and these highlighted cells are either new cells or the cells that were changed. Okay, and then we're gonna, so this is the after making all the changes and then running the problem. So this is your result. Now we're gonna talk about how to get there, how to get to this, but at least you have your final result as a reference. Okay, so let's see. Let's suppose that the Chicago, okay, Chicago had demand of 4,000. Now, what if its demand is now 5,000? So let's see what would happen. Now I'm going to go back to the original, solution and then make the corresponding changes. So what I'm talking about, maybe okay. So I'm talking about maybe I shouldn't. I don't. So I'm like this one. I'm changing this one. Okay. So we're saying, what if the demand in Chicago is now 5,000 instead of 4,000? So now let's see what will happen. So I make this 5,000. Okay. Now we could see, of course, now the total demand is 1,000 higher than before. Now it's 14,500, and that exceeds the total supply. So if the demand is higher than the supply, then there's a problem. Okay, so then it's not possible to meet all the demand. So we gotta kind of accept it as a fact and do the best we can. So we can't actually force, to force anything. So basically, we will take for granted that some of the demand will not be met because we just don't have enough supply. But within that framework, we want to do the best we can. Okay, so we want to meet the most demand we can, and we should be able to meet how many units of demand with a given supply. So we can't satisfy 14,500, but how many can we actually supply? 13, right? 13,500, because that's what's available. So 13,500 of these demand we should be able to satisfy. So there will be how many units of shortfall, right? 1,000 units of demand that will not be met. And so we want to kind of allocate that in the smartest way, in the best way, the most efficient way. Okay, so not everybody will have all their demands met. Okay, so now we're going to, given that, we're going to do the best we can. So let's see. So the trick here is to make these dummy variables. And remember what dummy variables are. They don't really have a physical, they don't actually correspond to some physical quantity. They're kind of like a placeholders for something, just to help us help us model the situation. So what we're going to do is we're going to create dummy variables for each destination. We're going to have a dummy variable that represents demand that is not satisfied, the shortfall or the unmet demand. Okay, so we're going to go here. So let's see how this thing will change. And I'm going to just take some notes here. And let's see where we are on our handout. Okay. So it's the second to the last, I think. Okay, well, the result. The result of making the changes is in the second to the last page. And I'm going to make the corresponding changes. Okay. So remember that the variables were xij, right? So xij was the amount shipped from origin I to destination j. Okay, so that was the amount shipped. Now we're going to have, so that's here. Now we're going to have for each j, for each column, we're going to have an extra variable, and we're going to call it 4j because, well, there are 3 rows in each column. Now we're going to adding the 4th row. We're going to add the 4th row. So here we had 1, 2, 3, and now we're going to add the 4th row here. So it's going to be 4, 1, 4, 2, 4, 3, 4, 4. So those are with the indices of your new variables. And so we're going to say x4j is equal to the unmet demand at destination j. So that by destination we just mean places that need the stuff, like the distribution centers. Okay. So what we're going to do is we're going to go over and say, okay, so how this will change is we have 1, 2, 3, 4. Now these were the constraints for the rows, right? So 1, 2, 3 were the row constraints. So it was row 1, 2, 3, and then we had here a column. Column 1, 2, 3, 4. Now we have this extra row here, so we'll need another constraint here. So what we'll do is, okay, I'm gonna go over here, insert a new one. So I'm gonna say x41 plus x42 plus x43 plus x44. And what does this represent? So each term represents the unmet demand at some specific destination. So here we're saying the unmet demand at destination 1 plus the unmet demand at destination 2 and then 3 and then 4. If I add them all up, that's the total unmet demand. And that should be, let's see, what is the shortfall we expected? 1,000, right? So 1,000. So that's the difference between the total demand and the total supply. So that must be 1,000. So here, what we are saying is total unmet demand must be less than or equal to the total shortage. And then what else? So we have. What about the columns? So we want to say something like total amount shipped to. Okay, now this is no longer be satisfied. So so we won't be able to meet all the demand. So these are not realistic. But what we want to do is something like total amount shipped to 1 plus the amount unmet demand. At 1 is equal to demand at 1. And so basically we're saying now we're allowed to have the total amount shipped to 1 could be less than the demand. Because there's this little thing here, this like placeholder that says, okay, here this is the amount of the shortfall. So the total amount shipped plus the amount of shortfall will be equal to the demand at 1. And then we will kind of interpret, and I'll just write 1 and the same pattern. Okay. Okay, so we'll say here, etc. etc. Okay, so here, what we'll do is we would just add that variable plus, plus x. Okay, it was x31, right? Now it's plus x41. So I'm just adding the extra variable. x41 is the unmet demand at destination 1. And then I just do the same thing here, plus x42. That's for the second destination. And I just keep going like that. And x33 plus x43. Then here we have x34 plus x44. Okay, so basically here you have the column sums. So you go to each column. If I add up all the 4 cells in the column, should be equal to the demand. And the last cell here, like 41 and 42, these guys represent the unmet demands at these different columns. Okay. And then now we're gonna go over here and make the change. So we're adding extra rows here. So I'm gonna go over here and insert a row right here. It's gonna say insert here. Okay. So this is going to be 4 unmet demand or shortfall. Then here I'm going to add the same extra row, and it's going to be 4 unmet demand. Okay. Okay, and then what else? So actually, if you see here, you will see all the steps here. Okay. So what we're doing is we're adding a dummy origin called unmet demand. That is an extra row, and the shipping cost should be 0 because the unmet demand is not like amount that is being shipped. So there is no cost involved. So the unit costs are 0 for the unmet demand variables. So what did we just do? We added a row to the data table, and we're going to put a 0 as the unit cost, and then supply total demand. Okay, so we're going to go over, and then and so forth. Okay, so let's go back here. So here we're going to say put zeros because these are the costs. Okay, so again, these are the amounts that are not being shipped. So there is no shipping cost, so the costs are 0. And then here, we want to put 1,000 here. Right, put 1,000. Okay, so 1,000 here. And then here, I'm gonna just update this thing here. Okay, what is this thing saying? Okay, that's adding this, and this part I'm just going to kind of drag this down to include the 1,000. Now it'll give me same values, 14,500 for both terms. So there they are. Okay, so we have that. And then what do we do now? Well, let's see what we should do. Okay, so we did the first step, and the second step we added a row in the second table, and then we're going to copy down the constraint from the previous row. So let's go over here and update the constraint. So we have here, okay, so row total is less than or equal to supply, and we want to have a constraint like this. The row total is less than or equal to 1,000. So row total is equal to 1,000. So we want to just, and I think if I just drag this down, that should be able to get it, right? Is that right? Right. So here is a sum of the fourth row and less than or equal to 1,000, which we picked up from here. Okay, so we did that. That was and then we want to update the column totals and the total cost. So like here, column total, this is including the original variable. So we want to include the new one. This is like an X401 we want to include. So I just kind of drag this down, expand the selection. Okay, and do I need to make any change here? No, nope, that's fine. So I just need to drag this to the right. So all the column totals will include the new variables. So let's check over here, and right, so it should be including the new 4142, 4344, those variables. Okay, and then we are also told to update the total cost over here. Okay, so total cost is the sum product of the two tables. Now we gotta add the new rows from those two. So I just drag this and expand the selection here, and here we expand this selection. Okay, so now we have including the new rows, and that's that. That's the total cost. Okay, let's see. Do we need to do anything else? Let's see. So I think the model part, Excel model part, is done. Okay. So does this make sense? Any questions? Any questions? Okay, now we're gonna go to Solver. We're gonna go to Solver and make the appropriate changes. And so here, let's see, the objective. Do we need to make any change here? No, because it just kind of, Solver adjusts the cell addresses. So when we move things or when we insert things, it'll adjust the, so it'll still refer to the correct cell. Right. And okay, and the variable cells, it says here B15 through E17. Now, is that okay? Well, we gotta add this extra. Right, so here is we gotta go with the 18. Right, so this would be like, basically I'm expanding it to include a new row, the fourth row here. Okay, and what about over here? F15 to F17, that's over here. Again, we gotta add that new row here. So I'm gonna change, either you could change it and expand, or you could just add a new row, either way. So I'm gonna actually change this. And the left-hand side, just expand to the last row here. And the right-hand side, okay, and include that 1,000. So we're gonna have 4 cells for left-hand side, 4 cells for the right-hand side. So we say okay. Okay. What about this one here? B19 to E19. So that's B19 here, B, C, D, E, and then equal to, it says B21 through E21, and that's over here. Oh, okay, so that's fine. Okay, so this part doesn't need to be changed in solver, and this part we just needed to change to include the extra constraint. Okay. Okay, ready? Okay, and we just click on solve. Let's say solve, and here is, let's see what we got here. Okay, so who is losing out here? Which distribution center is not receiving all it needs? Hmm? Can you say it again?
Boston.
Yeah, right. Okay, so Boston, right. Boston, oh, here it is. Okay, so Boston has unmet demand of 1,000. So it's not receiving all it needs. It's receiving 1,000 lens, so it needs 6,000. It needs 6,000, but there's a shortfall of 1,000, so it's receiving only the 5,000. But given that, at least we could say our total cost is the minimum possible. So this does minimize the total cost, given that we are still going to have some shortage. And then let's kind of modify the solution here. So Cleveland to Boston is, now we are giving 2,500, and then Cleveland to Chicago is 2,500. And Bedford to Chicago is 2,500. This hasn't changed. And York to Boston is 2,500. Okay, wait. Okay, so 2,500, 2,000, and 1,500. And this, okay. So these 2 rows haven't changed. Like here, there was a change. So here there was a change, and that adds up to 38,500 as a total cost.